Our lesson for today will be looking at chemistry 1502. The topic for today is isomers. Subtopic is positional isomer. Lesson 102. Let us start. Our first lesson video based on isomers, lesson 101. We have looked at different types of isomers by just listing them only, and then we've started explaining the chain isomer in detail. So by now we know what is an isomer and what is also a chain isomer. The first lesson video of homologous series, it was alkanes. Then we also looked at alkanes, alkenes and alkynes. We've looked at different types of properties. So in this position isomer, we will be looking at those homologous series. We can introduce another positional isomers once we are exposed or we've gained knowledge on the other homologous series, which is the ethanols, the alcohols, the haloalkanes, the aldehydes, the ketones, carboxylic acids and esters, amines, and the cyclose. But for today, I'll just use alkenes and alkynes because those are the homologous series of which I am 100% sure you know of. So when you talk about a position isomerism, it is due to different in the positions occupied by the particular atom, group, substituent in the same carbon chain, or due to different positions of double or triple bonds in alkenes and alkynes. Let us look at C4H6. You will tell me the name of this once we are done with the Lewis diagram. So you can see that we cannot have 6 hydrogens unless we have a double bond. So let us just put it here. So we have 1, 2, 3, 4, 5. There's something wrong here. Should have another hydrogen here. So you can see that we don't have 6 hydrogens. This simply means that we have a triple bond. Trying to assist you on how to quickly draw a Lewis diagram provided you're given a molecular formula, especially when we are looking at this organic chemistry. So let us just remove this hydrogen here. Then we know that also this will disappear, and then we have a triple bond here. So we can see they all obey the octet rule. We don't have any charges. Their formal charges will definitely be 0. So we have 1, 2, 3, 4, 5, 6. So we can see that this is but 1I. It's butyl. The triple bond is on the first carbon. That is why we have this. So looking at the position isomerism of this, if we can just take this triple bond here and shift it here, meaning that we are going to have something like this. Now you can see the triple bond has shifted, but we still have 4 carbons, 6 hydrogen. It's just that the position of the triple bond has shifted. So what is the name of this? This will be but 2I. So these structures are one of the examples of positional isomers. They are both isomer to each other. They are isomerism, then specifically position isomerism. For the sake of a different example, because we can use alkenes also, but just shifting the position of the double bond to yield isomers. So for the sake of examples, let us look at this. We call this a haloalkane because you can see that we have a halogen and then we have single bond between carbon and carbon. So this is alkanes combined with halogens. We call them haloalkanes. So another positional isomerism is when we take this and we put it here, meaning that you're going to have something like this. Once you understand these basics, it will be very simple for you to master the reactions. So you can still see that we have maintained the number of hydrogens, the number of carbons, and we still have our halogen, but the position is different. That's it for this lesson video. This is Wahula SJ. Thank you very much.